Hi, hello, vanakkam, and welcome back to yet another episode on your favorite Little Slaw YouTube channel. So, today in this video, we are going to see about the thread life cycle with example. So, totally, there are six different states for every thread, and we will see the different states and we will see how does it work and with the other examples on how do they really work. So before we move on to this video, this is me, Vasan Sharmugam. I welcome you all to Little Sly YouTube channel. Please don't forget to subscribe to our channel if you haven't subscribed yet, and like, share the video with your friends, and post any comments or feedback in the comment section. So firstly, understanding the thread dump requires familiarity with various states a thread can traverse, which is often referred to as the life cycle of the thread. So now let's deep dive into the states of the thread with the examples. So first, let me start with the first state, which is the new. So this new state or this state marks the inception of a thread. So when it is created, a thread enters the new state and has yet to commence its execution. So it just enters the new state and there is no execution that's been commenced yet. So for example, let me take a scenario where a Java program is initiated a new thread object but has not yet called the start method to begin the execution. So until the start method is invoked, the thread remains in the new state. Yeah, so that's about the new state. So until it's been called, it's still in the new state where it's been created. So that's about the state, the first state, which is the new state. And now let's move on to the second state, which is the runnable. So when it comes to the runnable, the thread gets ready for execution to the runnable state from the new. So it moves from the new state to the runnable state. So at this stage, the thread may either be actively processing a code or waiting in a ready to run state. For example, so imagine you have a multi-threaded application where multiple threads are concurrently executing tasks. So each thread, after completing its task, and giving its control back, it allows other threads to execute. On the other hand, they remain classified as runnable, whether they actively process or they can be waiting for an execution. So they consider as the runnable. So let me do a quick reiteration of this. What is a runnable? So runnable is something that's been transitioned from the new state to the runnable state. So in this stage, the thread will be actively processing the code or it will be waiting in a ready to run state. So that is about the runnable. And now moving on to the third stage, which is the blocked. So when a thread enters the blocked state, it is because of the reason where it is trying to attempt to access a locked section of a code which is held by another thread. So that's how the thread enters the blocked state. So it's trying to attempt or it's trying to access a logged section which is held by another thread. So when it is trying to access, it gets into the blocked state. So upon unlocking the section, the scheduler moves the blocked thread back to runnable, which is to the second state. So when it is unlocked, it comes back to the runnable. So for example, in a scenario where one thread holds a lock on a shared resource and another thread is attempting to access it. So the second thread enters the blocked state until the lock is released before it is proceeded, right? So that's how the blocked state has been created. So for example, let me just reiterate about the blocked state. So a thread enters the blocked state when it is trying to access a logged section of a code held by another thread. So until the thread tries to attempt or until the thread is attempting to access a logged section of a code, it is still in runnable. So the moment it is trying to attempt to access a locked section of a code which is held by another thread, the thread enters the blocked state. So that's where the blocked state comes into the picture. So again, for an example, so when one thread holds a lock on a shared resource and another thread attempts to access it. So in this scenario, the second thread enters the blocked state until the lock is released, which allows it to proceed for its execution. So that's how the third state, which is the blocked state. Now entering to the fourth state, which is the waiting. Let's see what is a waiting state is. So the threads awaiting response from other threads to meet certain conditions reside in the waiting state, right? So I have a thread which is waiting for a response from another thread to meet a particular condition which is residing in the waiting state. So once the conditions are fulfilled, the thread moves back to the runnable. So for example, in a producer consumer scenario, imagine a consumer thread waiting for the producer to produce an item. So the consumer thread enters the waiting state until an item is available for consumption, right? So it's like the thread will be, so for example, if you're ordering a pizza in a pizza shop and you have given the order, the producer has taken your order and he starts to prepare it. So until he delivers you the pizza, you'll have to wait. So that is the waiting state. So in the terms of threads, the thread will wait from the other thread, which is the producer, to meet certain conditions, which is he has to deliver or he has to fulfill the condition so that the waiting state will be moving to the runnable, right? So once you get your pizza delivered, you can come back and you can start doing your next action. So that is how the waiting. So this is very simple to understand in terms of the threads. And then moving on to the fifth one, which is the timed waiting. So let's see what is a timed waiting. So the threads enter the timed waiting when invoking methods such as wait or sleep or join or park. So these are some of the methods which is used to make a thread to wait on the timed basis. So they remain in this state until the timeout expires or until it is notified. So for example, a thread that calls thread.sleep of 5000 in this case to pause the execution for 5 seconds, because 5000 here is 5000 milliseconds, and when we convert the 5000 milliseconds to seconds, it is just 5 seconds. So during this period, the thread remains in the timed waiting state until the sleep duration elapses. So that's the timed waiting, and this timed waiting thread will not wait for any other threads. It just wait based on the methods, which is the wait or sleep or join or park. And then the last thread, which is the terminated. So this is the last thread for any last state for any thread. So a thread exits the life cycle upon termination, which releases the CPU resources and stops to exist. So the termination occurs, it can be either after the completion of a program execution or due to exceptional circumstances. For example, the segmentation faults or because of any unhandled exceptions. So for instance, you are considering a thread which is responsible for performing a specific task within a program. So once the task is completed, the thread naturally terminates, freeing up the system resources. So we are running a Java program. The moment it completed its execution, automatically it frees up its system resources, and in turn the thread gets terminated. So by understanding all these nuances of each thread state and their implication aids in effective thread management and debugging in concurrent applications. And when you are understanding all these states, this will definitely help you when you are doing your thread dump analysis in terms of increasing the performance of the applications, because most of the time the issues reside in the thread states, like the blocked state, the waiting state, or the timed waiting, because in some scenarios where there might be a code which will have a timed waiting, so you will have to check all these scenarios, you'll have to understand all these states, and then based on that you'll have to come up with your analysis and results and the tuning recommendations. So with that, I come to an end. And I definitely believe this video would be very, very, very useful to you. So until I meet you in another interesting video, it's bye bye from Vasan Shanmugam and your favorite Little Slaw.